The posterior pituitary gland releases oxytocin and ADH.
Yeah. But
And then everything else comes from the anterior.
Yes.
Okay, that was.
what the hypothalamus stimulates it?
It comes from the brain technically, and it's just neurons that are coming down instead of blood. Does that make sense? Like, so the difference is you got the hypothalamus, this is the region of the brain, right? Right above the midbrain. And down here you got this thing,
Yeah.
right? So you got the anterior, and then you got the posterior
Okay.
pituitary glands, right? And so what the difference is the way they talk. So they both have that long word, that hypophysial, either tract or portal, right? They're both the same word, but they end in tract or portal. So if I was you, I'd just worry about memorizing those two parts, right? Tract or portal. And so the way I think about it is like posterior is like in the back, right? So posterior is like something that's like in the, I guess like almost in history, you could say. So I think tracks, like on a train track, trains are older than like cars and stuff like that, right? So I use the track as the posterior, and the portal, like, it's like Stargate going to the portal, future, anterior, right, in the front. Does that make sense? And so what happens is the portal uses blood to come down and communicate, and that's why everything's released from the hypothalamus as a hormone. And it only ends in something called releasing hormone. No matter what it is, if it says RH on it, you know it comes from the hypothalamus, and it's talking to the anterior pituitary gland. If you see those two letters, you automatically know that, right? Because they all ended with like growth hormone releasing hormone, gonadotropin releasing hormone, like corticotropin steroid releasing hormone, whatever it is, right? They all have their own releasing hormone. Now hormones, because they follow blood down. These guys have just neuronal tracts, axons that actually come down from the brain, and it sends action potentials down, which stimulates these cells to release ADH or oxytocin. And what stimulates those is just like it talks about in your book, like oxytocin, mechanical stimulation of the breast, or baby entering birth canal, or whatever the thing is. It's going to go up and tell the brain to send action potentials down to do that. Or maybe, how about this? A decrease in blood osmolarity. Will that stimulate the brain to increase action potentials to release ADH? True or false?
Decrease in osmolarity.
True.
What do you think? It's kind of a tricky question. What do you think?
Repeat it again.
A decrease in osmolarity. So we're talking about the blood, okay? So a decrease in blood osmolarity. So think about in your head, what does that mean?
Means your blood's getting thicker.
Blood's getting thicker. What do you think it means? What is the definition of osmolarity? What did we talk about 264? This is
So
a while
the
ago,
decrease,
so-
osmolarity is the solutes in the blood.
Yeah.
So there's a decrease in the solutes and an increase in water.
Oh.
Or
So
the water stays
so the
same.
blood's getting more dilute or concentrated?
Dilute.
Dilute, right? So that means you have more water than solutes, right? Okay, so let's look at this. So if you have a decrease in osmolarity, is the brain going to tell the anterior hypothalamal hypophysial tract to increase action potentials or decrease action potentials? What do you think?
Everything wrong.
It would decrease it. You're right. You're right. So, but like, why?
Because ADH, if there's the presence of ADH and there's aquaporins near the collecting tubule in the kidneys,
Yep.
which means that water will be stuck in the body instead
And
of
it'll
leaving.
reabsorb it, right? But we want it to leave
Yeah.
because decrease. So we want to decrease the amount of ADH in the body, which will then hopefully bring this back up to normal, right?
Yeah.
Whereas a high osmolarity would do what?
Would increase ADH.
It would tell the brain to increase action potentials going down here to release more ADH, which would then hopefully absorb more water, and then decrease the osmolarity back to normal.
Okay, there was a question, a practice question, which said that like if somebody had their posterior pituitary gland surgically removed, and so their levels of hormones went down for a little bit, but then they stabilized again. Why? And the answer was that the hypothalamic neurons released directly into the blood, or something like that. Would that make sense?
Yeah, makes sense.
But do the hypothalamus release ADH, or they release stuff onto cells to make ADH?
So do you remember how like in 264 we went over this thing? It comes down, and then it had these little sacs right here that did this thing.
Yeah.
And what was the average neurotransmitter that we talked about? acetylcholine, right? And so what is a hormone? What is a hormone? Just what do you guys think of like, how would you word a hormone?
Like anything that communicates, right?
Yeah, what is acetylcholine?
Neurohormone.
It's basically, it's a ligand or something like that, but it's a neurotransmitter, right? It transmits a message. What do hormones do? They transmit messages, right? And so they're just a ligand, is all they are, really, when you think about it. They're just ligands. They're either made of lipids or proteins, which some water, lipid soluble. And so what if we just said that these hormones in those sacs contained ADH or oxytocin? Does that make sense?
Okay.
And so that's what we talk about in the posterior, it's using axons to release hormones, whereas the anterior is using blood. So it has this in a ligand, that means there has to be a cell here that's going to release, that reacts to that ligand, which then will cause a different change in it, the whole G protein thing, right? And then release some hormones.